Okay, so today we're going to look at transition matrices. So transition matrices is like another application that something we can use matrices for. And it is when we use them we've looked at like what has happened in the past, so sort of like a trend, and then we create a transition matrix and we use it often to find out what will happen in the future if it keeps following this pattern, and it'll make sense in a minute. So let's go through this scenario. It says, suppose that we have a certain town that you have two choices of activity each Saturday night, either going to the movies or staying at home. Suppose further to that it is being established that 20% of the people who go to the movies this Saturday will go again next Saturday. So what you see with transitions, we often start up with a diagram, and they've written it down here, but just to show you. So we've got the movies, and then we've got you stay at home. Okay, so what they're saying, and they're going from Saturday to Saturday because the activity every Saturday. So when they say 20% of the people who go to movies this Saturday will go to the movies next Saturday, what we often see this in a transition diagram, first of all, this is a transition diagram, is we see this. So you'll see an arrow that's going from M back to M, and they'll say it is 20%, okay? And then if the next one, they say 40% of the people who stay at home will go to the movies next Saturday. So in that piece of information, we're at home, and then the next time they go to the movies, so we know that's 40%, okay? So that's how we can set up the diagram. So here, I don't know why they put an S when they called it stay at home. So boys, do you want to change that to a H? Because they did say up here they wanted to call it H, stay at home. I think they made a mistake and put S there. Okay, so fix that up in your notes because they did ask us to do that. All right, so we can sort of see on the diagram they gave us, they've got those two pieces of information there that we also found out, but they've got a couple of other ones there as well. So we can change these diagrams into a transition matrix. So down here is an example of a transition matrix. So if you have a look, what type of shape is this transition matrix? Down here? It's a square, and it's a 2 by 2. Now it's a 2 by 2 because we've got two things happening, like movies. And guys, sorry, could you fix this one up again as well? Change that to home so you don't get confused. All right, so what we're going to do is, you'll see we're going to set up a matrix. This is a transition matrix. I'm going to do it with you to show you how they got that. And they often call it T, how they got that one down there. All right, so we often write that we're going to say start here. So maybe this was one Saturday, and then we end here, or start or end, whatever. Okay, so if we write along here, we've got movies, stayed at home. Yep, movies, stayed at home. So we always start at the top. So if you have a look at this, what we wrote up here in the purple, we wrote, if we were at the movie, went to the movies this Saturday, then the next Saturday, so we might say next here, and you might say this Saturday, and this is next Saturday. So because when it was said 20%, we changed those percentages, to a decimal. So when we change 20% to a decimal, it becomes 0.2. So can you see we're on the M to M spot in that square matrix? So we write 0.2. Now, with the other piece of information that we wrote in green up here, it was we're at home this Saturday. So you go here, but we went to the movies the next Saturday. So we write this as 0.4. Okay? So that's how we got those two. Now, the other two are listed here in this diagram. So let's go pop them in. So if you have a look, if we were at the movies, we went to the movies this week and we stayed at home next week, then start at movies and go to home, we get 0.8. And if you follow the other one, home to home, so home in this home and next week, you get 0.6. So what you're going to notice, if I added up those columns, if I added these numbers up, what does that number equal?
100 or 1.
Oh, it equals 1 because we change it to a decimal. Good, okay. So that was 100%, yeah, because we are dealing with all the people. They either went to the movies or they stayed home. So if you look at this other column, it adds up to 1, yeah? So transition matrices. So if you say, so you might want to write a note here, transition matrices, columns always add up to 1. So transition matrices, columns always add up to 1, okay? And we can see we change the percentages to decimals when we put it into a matrix. So this is called a transition. This is a transition diagram. Okay, so this is another thing that a transition diagram, very easy. What we call them is open-ended questions. Or I could give you this information over like in the dot points and ask you to create a transition diagram. So I'm not giving you anything else but the information. That's what type of questions you get for an analysis question, where we're not putting it, we're just saying display this data, and you also have got to interpret it. Today, we change. All right, setting up a transition matrix. An amusement park has 2 rides. These are the Ferris wheel and the merry-go-round. So there's our 2 things. After each ride, children can choose which ride they want to go on next, and the park observes the following. So 70% of the children on the Ferris wheel go to the Ferris wheel again. 40% of the merry-go-round go to the merry-go-round again. Find the percentage of children on the Ferris wheel who will go to the merry-go-round next time. So what this is, when you have this, it's probably best we set up a transition matrix. So let's set up over here, on the side here, let's set this up as a transition matrix. Now, we know it has to be square. So it's either going to be 2 by 2, 3 by 3, etc. So what will this one be? How many things have they got to choose from?
2.
2, good. So I'm going to write Ferris wheel first up here and merry-go-round there. And then my same order has to go down the side. And remember, and then you might want to write, so this is this time, if you like, and this is next time. Okay, so let's put in the information they gave us and see if we can fix up the rest of it. So up here it says 70% of the people who are on the Ferris wheel go to Ferris wheel again. So what number will I put in? And I'm going to put it in this spot. What number am I going to put? F to F is?
0.7.
Excellent, 0.7. Why am I changing it to 0.7? Yeah, because we're going to change the percentage, 70%, to a decimal. Good. So then the next one is the merry-go-round to the merry-go-round, which is actually this one. See? M to M. These ones are often the easiest to pop into your transition because you don't get confused. It's definitely 1 back to the next one. All right, so this one, what number am I going to put? 0.4. Awesome. Now, can I work out these other spots? Do I know what they are?
Yes.
Yep, good. All right, let's do this one under the 0.7. What's that one going to be?
0.3.
Excellent. It's going to be 0.3. Why is that?
Adds up to 1.
Excellent, because they've got to add up to 1. So this one missing over here is 0.6. Good, because we know they have to add up to 1. Everyone clear about where we're getting them? Yeah? Good. So now when they ask me the question down here in A, it says, it goes, find the percentage of children on the Ferris wheel who go to merry-go-round. So we're on Ferris wheel and we go to merry-go-round. So our thing says 0.3. So what does that mean? So Ferris wheel to merry-go-round is 0.3. So therefore, how much percent?
30.
Yeah, good, 30%. So once we write it, just pop a box around your answer. So there I'm giving a little bit of information so the person marking your thing can understand where you're getting it from in case you've got mixed up. All right, the next one, find the percentage of the children on the merry-go-round. So merry-go-round, that will go to the Ferris next time. What's that one?
60.
Yep, 0.6. Sorry. All right, so we wanted to know what merry-go-round to Ferris was, and when we had a look at that, that was 0.6, so therefore 60%. And the last question, they asked us to construct a transition matrix, which we've already done, so I'm just going to pop C up there because that's our transition matrix. All right, the observant sales assistant has noted whether customers buy hot food or cold food in a store for lunch. They noticed that 80% of, so we know, I'm going to draw this time. While I'm reading this information, I'm going to draw a transition diagram. Okay, so I've got hot food and I've got cold food. And they said 80% of those who buy hot food for lunch will buy hot food again. So hot food to hot food is 80%. So when we do the diagrams, we like to write it as a percentage. And it says 60% who buy the cold food for lunch will buy hot food again. Will buy cold again. So cold to cold is 60%. All right. So if we've got 60% of the cold going back to cold, how many left of the cold? If you've already got 60, how many left? 40. So we know 40 must have gone over to hot. And what about if we've got 80% staying, we've got 20% that must have gone that way. Okay. So construct a transition matrix. So I actually just started off with a diagram, but we need to do a transition matrix. All right, so you're going to draw a square. You will put the letters above it, boys. So all these pieces of information on your transition, please. And hot to hot is pretty easy. They give you that one, and they gave us also 0.6. So you can check. We said from cold to hot was 0.4, and that's good because that's going to allow the column to add up to 1. And we said from hot to cold was 0.2. So these guys, I'm just going to leave it, but they should add up to 1. Okay, so we've done the setting up of a transition matrix. So if they gave us a bit of information, we could set one up. Now what we need to know is how we're going to apply this transition matrix. And what we're going to do is we're going to apply it so we can predict maybe what people are doing. So in our scenario, remember they were staying home or going to the movies. So we're going back. So can you change that? Sorry, again. It was really frustrating that they've done that. Okay. So we are going to use, so we can use it to predict how many, if we know how many people are in these towns, we will know maybe next Saturday how many people we think will be going to the movies and all that. And why could then businesses can be prepared? They can go, right, we're going to expect this many people. We'll have, so many choc tops or whatever ready. All right, so using this information alone, a number of predictions can be made. For example, if 200 people go to the movies this week, the transition matrix predicts. So they said if you've got 200 people going to the movies, so 20% of these, or 40, so 20% of, if you want to, of 200 is 40, of these people will go to the movie next week. So you can see that here we knew movie to movie was 20. And then we know the other 80%, so the other 160. So you can see here, this is how they're working out the percentage. So if you might want to write on the side, percentage of an amount is equal to, you write the decimal number and you times it by the amount. Okay? So, and then they've done that further. If 150 people stayed at home, and then they've worked out, and you can see how we can use it to predict. So, thus we can predict that if 200 people went to the movies this week and 150 stayed home, the number of people going to the movies next week is 100. So, because you've got to remember, there's going to be some people coming new to the movies who stayed at home the week before, and then there's the ones that are already at the movies. So that's why in total there's 100, and then they're going to say about at home the next week there's 250 people at home. There was some of the people who remained at home, and there's some people who decided who were coming from the movies. So what we do is we're going to do a quicker way to learn to work out those numbers. So what we do is, all right, at the moment they're going to set you up with, okay, the following transition diagram can be used to describe the movement between the Ferris wheel and the merry-go-round. So there he goes. With question A, what percentage of the children on the Ferris wheel are predicted on the Ferris wheel next time? So what's AI? From Ferris wheel to Ferris wheel? What are we going to say? 80%. Yeah, they're asking what percent. Okay, 2, what go from the Ferris wheel to the merry-go-round the next time? 20%. Good. So we're looking at Ferris to merry up in the diagram, or you can look at the matrix. So here it says 140 children went on the Ferris wheel. How many of these children do you expect to go on the Ferris wheel? So how many, we said that there's 80% go from the Ferris wheel again. So we're going to say 80% of that 140 children. So if we change that statement into a mathematical equation, we change it to 0.8 and then we times and 140, and what do we get? What does that equal? So 112. Okay, now the next one, they want to know, of the ones in the Ferris wheel, how many go to the merry-go-round? So we said that was 20%, and must be 20% of the 140 on the Ferris wheel. So if we change that to an equation, mathematical equation, so what does that end up being? 28, is it? Yep. Okay, so if you do that on your calculator and see, if 140 children went on the Ferris wheel and 80 went on the merry-go-round, how many will we predict to go the Ferris wheel? So we needed the Ferris wheel to the Ferris wheel, which we said, we actually worked out here, which was 80%, and we said that was 112 kids. But we also need to add the ones that were on the merry-go-round going to the Ferris wheel. So if there was, what percentage was that when we went merry-go-round to Ferris wheel? 30? Are you happy with that if I said 30?
Yeah.
So it's 30% of the kids on the merry-go-round, which they've told me is 80. So we're going to have to, sorry, we've run out of room. Move that up. We're going to have to find out what that is. So that's 0.3 times 80. So what does that end up being? 24? Is that correct? Yeah?
Yep.
So therefore, all the kids that are on the Ferris wheel the next time, so Ferris wheel next time equal the 112 plus the 24. So this 112 were the Ferris to the Ferris, and this 24 was the merry-go-round to the Ferris. So we end up with 136. So the following transition matrix T and its transition diagram can be used to describe customers choosing between hot and cold meal as given their previous choice. Okay, we've got it there. So let's say, of the customers who purchase hot food today, what percentage do you expect to buy hot and cold meals tomorrow? Okay, so of those who purchase hot food today, what percentage do you expect to buy hot and cold meals tomorrow? What do we reckon? I'm going to pause it here. So that was a little bit of a trap. So of those percentages, we know from hot to hot was 90%. And if you got the other scenario, and then they said who buy hot meals and cold tomorrow, that's 10%. So if we add 100% of the hot meal people, of the people having a hot meal, are going to either have a hot or cold next time, because that's the only choice. Okay, B. If the store sold 400 hot meals one day, how many of those who purchased a hot meal are expected to have a hot meal the next day? So we're talking about hot to hot. So what was that percentage again? 90%. So we're saying 90% of how many people had a hot meal? 400. So we'll change that to a decimal, and of means times in maths, and then we change it to 400. So 90% of 400 is 360. Yeah. You can do it on your calculator. Okay, and then if the store sold 400 hot meals and 500 cold meals one day, how many hot meals in total do you expect them to sell the next day? So we've got hot to hot. We knew it was 90% of the 400. Okay, plus we've got to add the ones who go from cold to hot. So what was that percentage? Cold to hot?
40%.
Yep. So it's 40%, but how many were having a cold meal on that first day? It says it in the blurb. So it's 40% of 500. So we've already done that 90%, so we could see that was 360. Just on a side note, you'd have to find out what 40% of 500 is, which is 200. Is that correct? Yep. So that's what I did. All right, so I found that, so I could add it to this. So how many in total had a hot meal the next day? 560. Good. So we just write a little, they're just asking that, so we can just write 560 underneath like that. Okay.